Hey guys and gals, Insomnia from UnrealTek.net, a division of BlenderTek.com. I'm going to do a quick video today showing you some Blender to Unreal Engine 4 workflow ideas and tips and tricks. User asked for some help regarding taking a mesh into Unreal Engine 4, and he had normals that were backwards, so I'm going to talk about normals a little bit and show you how you can swap them or fix them. And I'm going to talk about exporting to FBX and the settings I use to make sure static, skeletal, and animation blend or FBX exports, that is, export properly, and also how to set up your scene properly for Unreal Engine 4 units. So what I have here is just the basic stock cube, and I'm going to use it for examples. So I'm just going to grab it up along the Z1 unit so it's right on the floor, and then with my 3D cursor still at the bottom center, so at the very center, I'm going to hit Control Alt. See, do I have screencast keys in this level? In this version, no. But anyways, I guess you won't be able to see my keys. So what I'm going to do is I'm going to hit Control Alt Shift C, and that's to set your origin. I'm going to go origin to 3D cursor. Now this is a good habit to get into for Unreal Engine 4 meshes, is to put the pivot point right at the bottom center. That way they're able to be snapped on top of each other easily when building in levels. Just something to think about. Anyways, so what I'm going to go over next is setting your scene units for Unreal Engine 4. Unreal Engine 4 uses centimeters for its units, and Blender uses meters. You'll see if I go to the scene tab over here, it's got like a circle and a cylinder and a little light. Under units we have metric, imperial, and none. However, none and metric, as you can see, make no changes. You can see the dimensions 2 by 2 by 2. If I go to metric, turns into 2 meters by 2 meters by 2 meters. So Blender uses meters. That means anything you make in Blender is going to be 1/100th the size when you import it into Unreal. And just setting the size to x100 is not the proper way to do things. So what you want to do is select metric and change the scale to 0.010. So that'd be 1/10. So that's 1/10 of a meter is a centimeter. Obviously 100 centimeters in a meter divided by a tenth, that gives you 10. So that's going to make your cube a lot smaller. That is how big it would end up in Unreal Engine if you had not set your scale. Now when you try to scroll out, you're gonna see that your grid starts going away. That's because of our change to scale. So you need to go and open your end panel and go down to the view, and you want to change the end, your clip end, to a large number. You can go up to 100 meters, I think, but you can also just type in like 1 kilometer, I think is the max, and that way you can get just like normal. And sometimes zooming in very close, it'll disappear, and so sometimes you have to go less than 1 millimeter, down to 10 micrometers. Alrighty, so what I'm going to do is I'm going to scale this cube by 100 so it's back to what would be. You can see that gives you a little bit of errors when you're very, very small like that. I'm going to set it back to say 2 millimeters. Anyways, so this is what size it was before, 2 meters by 2 meters by 2 meters, and it will come out in Unreal that way. But one important thing to know, when you are exporting objects to Unreal Engine 4, and most game engines for that matter, everything should be zeroed out. So your locations should be zeroed out, your rotation, and your scale. So since I scaled it up before I export, make sure you always hit Control A and apply location, rotation, and scale. And since I'm already centered here, so 0, 0, 0 under location, I only need to apply rotation and scale. So as you can see, that zeroes out rotation and scale is 1x. That's called zeroing out the scale. So now it is completely ready for export. Getting into FPX export options. So FPX is the standard unit that Unreal Engine uses. Epic Games uses it. They've used it for years. It's what Maya uses, and because Maya is the industry standard, that's kind of why Unreal Engine supports it the most. So when you go File, Export, FPX, again remembering that you've zeroed everything out, go Export, and that your units are set to metric and decimal 010. So we go Export FBX, and then in the bottom left corner you're gonna get your Export FBX settings. There's a whole bunch to play with, and this is why it's important. So I'm just gonna go to my presets so I can show you what options to use. So I have for static mesh, so just for a basic prop, basically something that doesn't have any bones or anything, it's not animated. So in this case I want binary as the version. If you have multiple objects in your scene and you've selected the one you want to export, then choose selected objects. So basically what that would do is if I had, say, 2 cubes and I selected one, it would only select it would only export the cube that I had selected. Otherwise it would export both cubes together and it would combine them into one. So that's what export selected is. It's generally best to have one mesh per export per file, but you can work around that. So that's what selected objects does. Scale, you want that to always be 1 because our scale is 1, and our scene scale units in Blender is centimeters, 0.010 meters, so 1 centimeter, that'll be our scale. So that means everything will import properly. Apply unit, you can just leave it the way it is, I believe, and I think that helps you get to centimeters sometimes if you didn't set it up properly, but I still suggest doing it manually. Now your forward, oh, I have to change back to there. So your forward in Unreal Engine, positive X is forward, whereas in Blender positive Y is forward and X is left and right. So make sure that forward is X forward and up is Z up. Now luckily Blender is Z up, but Maya and Unity are Y up, for example. So we want Z up for Unreal Engine. Next, for a mesh export, we just want to select mesh. So if you've got everything selected, just select mesh. If you do need to select something else for some other reason, you can shift click to select another, but we just want mesh. You want all modifiers applied, but I do suggest taking care of any modifiers before exporting. Smoothing, you generally want it on face, but sometimes other ones can give you better or worse results depending. That one you have to play with a little bit, but I leave it on face. Loose edges, I turn off, that way you don't get weird extra polygons exported. Tangent space, it's kind of new to Blender, but I do leave it checked off because Unreal does use tangent space. And that's it for a static mesh. The rest really don't matter. You can leave them all unchecked or whatever they are, it's stock. So I'm going to export this. I'm going to call this just a standard cube.fbx. Now let's talk about normals, and then we'll go into skeletal and animations after. So the user was having problems with normals, so I'm going to show that right now. If you tab into edit mode and open up the end panel, if you go down to display, mesh display, you'll see normals, and it has 3 buttons, one for vertex or verti normals, and you'll see the size, it's 1 millimeter. I probably want to turn that up so you can see it's showing me what direction my vertexes are facing. And then if I uncheck that and go to the next one, it's lines. So that would show you which direction the lines are going. And lastly, faces, and this is the important one. So if I go into wireframe mode by pressing Z, we can see, if we go into a side view in orthographic, we can see that everything is facing outwards. Nothing is inwards. And it's more apparent if we make it, say, like 30 centimeters. We can see clearly that everything is outwards. Nothing's pointing inwards. If we go to top view, left view, or right view, front view, nothing's pointing inwards. So that means that every face you see is going to be completely seen. What that means, however, is that if I deleted this face, for example, if I was to view the inside of the mesh in Unreal Engine 4, it would be see-through. These back faces you won't see anything. They'll be completely transparent because the normals are facing outwards. So I'm going to export the mesh like this to show that problem. So I'm going to first of all make sure everything's zeroed, of course. So tab out of edit mode, everything's zeroed, perfect. So I'm going to export this file, export FBX. I'm going to use my preset for static meshes. I'm going to call this standard cube open face normal example, or just norm example. Alright, so what you can do if you, let me undo that deletion. So let's say I'm just gonna flip one of these. So I go Control F for faces and flip normals. So you can see how it changes the shading too. So let's say as you can see, if I go into top and right orthographic views, that this one is no longer pointing outwards. So that's going to be transparent even though it's physically there. So this would look exactly the same as if I had deleted this face in game. So to fix that, what you do is you select the face and then just hit Control F and then flip normals, and you want them all facing in the proper direction. Another thing you can try is to select everything and then go down in your T toolbar to UV/shading, and you can do recalculate normals or flip normals direction. Another way you can get a kind of preview of what it would look like in Unreal Engine is in your N panel, is to go down to backface culling. Now, backface culling is the actual technical term of what's happening here. So you can see now that if I flip the normals on this, Control F, flip normals, you can see that it's transparent even though it's physically there. That is exactly what you'll see in Unreal Engine. So that is why you can get weird looking meshes like this. So that's a good way to kind of get a preview of what your mesh will look like in Unreal Engine. So if I go to my T toolbar, recalculate, it's figured out that it's a cube, so everything needs to point outwards, but that will not always work. One last way to fix this problem that will always work is, let's say I had this cut up. Let me just get my Blender presets here. If I still have them, apparently not. Yes, there we go. Okay, so let's say I had this all cut up. And let's say I had this part extruded up. The normals are still all good. I have backface culling on. As you can see, it makes no difference. I'm going to leave it off for a second though. But let's say that for some reason these faces were the other way. So I'm going to flip them. I'm going to go Control F, flip normal. So they're now backwards. You can see the lines aren't poking you. I'm going to turn them down to about 20 centimeters so we get a better view. So they're now, so now if I turn on backface culling, you can see they're completely see-through. So that could give you problems. You know, this could happen if, whoops, if maybe if this was inset and then extruded in, maybe someone had designed it like that, and you can see, we can see some, but only whichever direction the normal is facing. You can't have normals in both directions in real-time rendering. So, again, obviously I could try to fix this by recalculating it, and in this case, backface culling, it has figured out, but it won't always. But so anyways, one way you can always fix this, let me just undo this back to where we were. So I've got these normals backwards. All you have to do is create some thickness to your object. So in this case, it could be as simple as extruding. So I'm going to press E, to extrude out. And I could just extrude out like 1 millimeter. I'm going to go equals 1 millimeter. And that needs to be negative because we're going in the negative direction. So it's just a tiny, tiny, tiny bit of thickness. But that way, it will go in the right direction, but we still need to make sure our normals are the right way. So this one needs to be flipped, so I'm going to flip that one. This one needs to be flipped, and all these ones around the edges need to be flipped. I don't even know if I can select them. So you can see that one doesn't have a line coming out of it, so I have to go Control F, flip normals. I'm going to try recalculate here. I think it's got it. Yep, it's coming out of those sides, and if I press Z, you can see it coming out down here even. So that's how you would fix something, is just to give it thickness. So let's say you had, I'm going to give one last example, you had just a plane. Now, this will show up in Unreal Engine from this angle, but if I turn on backface culling, if we look at it from the back, it's going to be completely gone. So the way to fix that, again, is to give it thickness. So that would be to select the face and do something like extrude. So I'm just going to extrude it a little bit, and I'm going to then flip this normal, Control F, flip normals, Control F, flip normal, Control F, flip normal. You want all the lines we set in the mesh display for face normals. And just for good measure, oh, this one's backwards. Oh no, because I extruded. This one is backwards too, so for good measure we would want to flip that. Control F, flip normals, and then what I could do is I could take this loop and I could just fill it in, or I can use F2 to fill like that. And the normals are all pointing outwards. So now if I turn on backface culling, I can see what it looks like in Unreal Engine. So now that would be that would have no hidden edges, and I could even grab it along the Y. I could grab it, I don't have vertex snapping on vertex. I could grab it along the Y, and I could come extremely close to the edge. I could grab it along the Y like 0.00001 millimeter. Just the tiniest bit. I'm just going to repeat that a couple times. Oops. I'll just go 0.01 millimeter. Very tiny amount. It's got thickness. It's like barely visible, but it does have thickness regardless. If we zoom in really close, we can see it has some thickness, and that will eliminate your problem. You can still have something extremely thin, but as you can see here, we still have the normals pointing in the right directions. So I'm going to export this just to exemplify that as well. So what I'm going to do is I'm going to make this one proper, but I'm going to take this one, I'm going to extrude it along the Z, and I'm going to make that one so it's see-through. And I'm going to do it so it's see-through the other way. I'm going to turn off backface culling. I'm going to flip the normal. So it looks like it's normal, except when we look at it from the other side. Now those ones are very close, they might bug out, so I'm just going to grab it along the Y a little bit. Just enough to get rid of those ears. Alright, so I'm going to export this now. Again, make sure everything's zeroed. I'm going to just call this standard cube backface culling.fpx. Again, making sure I am on my static mesh preset export. Okay, so let's quickly jump into Unreal Engine so I can show you this and a few tricks of how we did the auto recalculate in Unreal Engine or in Blender. How we can also try to use Unreal to do that. Alright, so we have Unreal Engine 4 open. So what I'm going to do is I'm going to import all of those cubes that I created, just to really quickly show you what you can do. So first of all, I'm going to import just the standard cube. So we import it, we auto-generate collision usually. The rest of the options we will get to when we talk about normals. So if you know your normals are right in Blender, and you don't want Unreal to mess with it, go into this advanced option drop down here and import normals, or import normals and tangents instead of computing them. Computing them will allow Unreal Engine to try to fix it, but it might do a better or worse job than Blender. The rest, generally, you're fine all on your own. Except import materials and textures doesn't work. You need to set those up manually, so I generally uncheck those and then just import. So we can see it gives us an error that might result in incorrect shading, but it's not an issue. As you can see, I can still import it. It's a regular cube and I can move around it, and no faces are missing, so that's fine. Next, let's do the standard cube backface culling. So what I'm going to do is I'm going to import normals and tangents to show you what it would look like. So if I import it, so well, this was the wrong one, so let me open up in the static mesh editor. So as we can see, remember the face that I fixed, we can see it from the front. We can see it from the back, but this one over here, that remember that it only had normals in one direction because it was only a plane. We can see it from this side, but when we go around, it turns invisible. So that is the problem with normals. Now, if I import that, and if I try to compute normals, and it gives you a couple options, you can try the two different options to see if they give you the proper results, and hit import again. It will try to fix the normals. So now we can open it up and see if it did. And no, it's not able to generate new geometry, so all it's going to do is flip any normals it thinks it should. And this is the way it thinks it should be. So it'll do the same thing as Blender's recalculate. So that's why things always need thickness. Next, I'm going to import the open face box to show the example, and I'm going to import normals again. So if I import that cube, remember it was just a cube with the missing face. You can see if we go around to this side, it looks like it's completely gone. But once we see one of the sides again that has proper normals, it just looks like a regular cube. So again, if we open this in the static mesh editor, you can see it looks fine, but that face that had the reverse normals means that all the back faces are culled. So again, if we re-import that, we can always try to compute normals, but generally it will do about the same job as Blender's recalculate. So as you can see here, it hasn't fixed anything. So that is how backface culling and normals work in Unreal Engine and Blender, and also exporting static meshes. Next, I'm going to quickly go through how to export a rigged mesh and an animated mesh. So what we're going to do is make a new file, and I'm going to make a cube. And I'm going to do the same things before. I'm going to set up my scene for Unreal. So I'm going to choose metric, scale 0.10, whoops, not 0.1, 0.010. And I'm going to open up my end panel. I'm going to change the end to 500 meters. I'm going to scale this by 100, so it's back to 2 meters. And then I'm going to Control A, apply rotation and scale to make sure everything's zeroed out. So what I'm going to do is I'm going to rig this box. So I'm going to add a armature, or first I'm going to set the pivot point. So I'm going to grab this along the Z, 1 meter, I believe. Yeah. So I'm gonna move the cursor back to center and Control Alt Shift C, origin to 3D cursor, so it's on the bottom nicely. And from there, I'm going to Shift A. I'm gonna add an armature, single bone. And so in Unreal, you always start with a root bone. It doesn't really matter where it is, but you always need a root bone. So what I do is I go to the bone tab and I call the first bone root, because Unreal works on a root bone process where the very first bone in the chain will be the root bone, and that's where everything will kind of start from. And that will make more sense when you play with it more. I'm not going to go into the specifics today. So you don't really want your root bone to affect anything. So what I'm going to do is instead I'm going to extrude a second bone that will do the actual animating. So the root bone won't be animated. So we have an armature. So what we need to do is obviously set it up with the cube. So I'm going to select the armature and then the cube. Hit Control P. Sorry, the cube and then the armature. Hit Control P. I'm going to set parent to armature deform with automatic weights. You can see my scales off, so I'm going to make sure I Control A and apply rotation and scale, otherwise it'll give you problems. And we can test this now by selecting the armature and holding Control Tab to go into pose mode, selecting that bone, and if I rotate it, you can see that it affects the cube. And we could maybe do some maybe we didn't want it to do the whole thing. We could maybe weight paint it a little bit. Let's get rid of a little here. Where are we blending? I want to subtract. There we go. So we'll just make it do some funny things. Alright, so now if we select that bone again and Control Tab to go into pose mode, now when we rotate it does funky things. So that'll allow us to do an animation. So let's just export this. When you do animations, after you've got your object rigged out, let's say this was a human, you generally want your base pose to be what you import as your skeletal mesh base. So if it was a human, it would be like a T or A pose, or maybe the first frame of the idle pose. So in this case, I'm just going to export it like this with no animations, no deformities. So basically the bones are all zeroed out is how you want to export a skeletal rigged mesh. You want all your bones to be zeroed out. So W at 1, the rest at 0, and scale 1. So what I'm going to do to export it now into FBX, I'm going to go File, Export, FBX, choose the same folder. I'm just going to call this, we'll call it Skeletal Mesh Rigged Box Base .fbx. So what people usually do when they call it is they go skel m and then underscore some name a box, and that skeletal mesh versus static mesh, but I'm just going to call it skeletal mesh rigged box base. So this will be our skeleton. So I'm going to go to my skeletal mesh setup. So again, binary, selected objects works the same thing. Scale we want, apply unit, X forward, Z up. Now in this case, we want the armature and mesh. I've found that I just I choose everything because I never put lamps or cameras in your scene, but you want to turn off lamps and cameras if you do have them in your scene. But it's best to delete them before exporting. That way you can just have everything selected to be sure. Of course you want modifiers applied, you want some sort of smoothing. I apparently have tangent space on or off, but what you want to do now that we get into the animation properties, only deformed bones checked off, custom properties off, add leaf bones off, the secondary, primary and secondary bone axis here you can leave stock, which is Y and X. But you want baked animation on, key all bones. You want all these 4 checked off here, and that should be it. And sampling rate and simplify 101 stock options, but make sure that baked animation is turned on, and make sure you have armature, mesh, other selected to export, and the rest is the same as static. So I'm going to export that. Now what I'm going to do is I'm going to just make a very simple animation. So I'm going to bring up my timeline. So I'm going to make a, let's say a 75 frame animation. So what I'm going to do is I'm going to add a keyframe right at the beginning. So I'm going to select that bone, not my root. It'll be root 001, but I would call this like spine or something, you know. So I'm only gonna animate this bone. So and we could even go into X-ray mode. So what I'm going to do is I'm going to insert a keyframe. Oh, we're in edit mode, that's why. Pose mode. We're going to insert a keyframe. I'm going to do a lock rot scale. I always use that. And then I'm going to go to the very end by hitting shift and right arrow. So I'm going to go to the last frame. I'm going to insert the same lock rot scale animation. That way it'll start and end at the exact same position. Now I'm just going to go and randomly rotate it. So on frame whatever I'm at, 16, I'm going to randomly rotate it. I'm going to insert a lock rot scale. I'm going to do the same thing here. Insert lock rot scale, same thing here. Insert lock rot scale, and then it'll go back to normal. So if we play this animation through, we see how it's animated. So we see what we want the results to be like. So again, and generally you want to start from frame 1 because Unreal Engine will use frame 0 as its reference pose. So you don't want to animate on frame 0. You want that to be all zeroed out. So again, we want to make sure that at frame 1 or 0, everything's zeroed out. You can go into object mode again, make sure your armature 0, 0, 0, 0, 0, 1, 1, 1 for scale. And that your cube or whatever your object is that you're animating again is also zeroed out the same way. So what I'm going to do is file export, and this time we're going to go for an animation. So I'm going to go into my animation preset. So again, binary selected objects. Selected objects won't work for skeletal stuff though, however, because obviously you only want to export the armature. And it'll automatically combine everything, so that won't really apply to skeletal things, I guess. Scale 1, apply unit, yes. X forward, Z up, same as before. This time we only want the armature. If we add the mesh, then it will think it's a skeleton. We only want the armature because that will export only the animation data. We want to apply modifiers. We want some sort of smoothing, same as before. And again, this time, same thing. You want to make sure that you have a baked animation and key all bones. You can see it even notes Unreal Engine 4 here. This is the most important, to key all bones. And something Unreal Engine 4 requires. So key all bones, NLA strips, all actions, 1-1. It's the same as the skeletal mesh, the skeleton setup. It's just this time we're only exporting the armature. So I'm going to call this skeletal mesh rigged box. I'm going to call it anim for animation 01. So I'm going to call this animation 01. Then I'm going to export. So again, remember, make sure that your scene units are metric 0.010 so that everything works properly. So I'm going to hop back into Unreal Engine 4. So now what we can do is we can import. First we want to import the skeleton, the base. So that's the one that we exported everything with. And so what you want to do is you want to import a skeletal, you want to import the mesh, you want no skeleton because we're going to generate one. And the rest generally you can leave as it is. We want to import normals because we know our normals are good. However, make sure you uncheck import animations. Blender will always export an animation on a rigged object. And I think Unreal Engine imports animations by default. So when you're importing a skeleton, make sure that you uncheck import animations, and you want to probably create a physics asset. And then the rest should be good for most uses. Sometimes if you're having problems, update skeleton reference, pose, and especially use T08 or use T0 as reference pose. That'll use the frame 0 as a reference pose. That can help sometimes, but these options will work for 99.9% of things. So I'm going to import, and you'll see we have some weight problems because I weight painted it. But you'll see now that if I open this, we have our rig box. And if we open up the next one, we have the physics asset. So you can see how it works now. So the armature is actually a root. That's the problem with Blender. It can cause issues, but usually not. Then we have our root, which shouldn't be animated. And then our root 001, which is our animated bone. So what I usually do is I delete. So I select in the hierarchy that bone. I hit delete to delete its collision primitive, and sometimes armature too. I only want the bones that are animating to have physics, but that doesn't really matter usually. So lastly, we have the skeleton. So it just has our bones, and we can play with it here and see that it's obviously working. So now to import an animation, so I'm going to import the animation file, the anim01. So this time what we want to do is we want to choose that skeleton. So that was skeletal mesh. Whoops, I spelled that wrong. Skeletal mesh rig box based skeleton. So choose a skeleton, and under the animation, generally exported time will work. And again, that should be completely fine just on its own. So we want to import. And so it's apparently giving us some errors, but now if we open that animation, it should play. But apparently not. Apparently something didn't work. So I'm going to reopen that base, and I'm going to overwrite it. What I'm going to do is I'm going to use T0 as reference pose. I'm going to try that. I don't want to import animations, and so I'm going to try importing again. And then I'm going to re-import this animation. So I'm going to choose the skeleton again. Skeletal, I can't spell today. The animation length, exported time. Another thing, sometimes animated time will help, so we'll try that next if that doesn't work. Yeah, that should be fine. So import. No, it's giving me some sort of weird issues. So I'm going to try this animation one last time, since we did try T0 as reference pose. I'm going to try animated time. Sometimes that can help. Skeleton, skeletal, import. No, it doesn't look like it's going to work. So we obviously ran into an issue. So let's try that again. So we've got our animated object. So everything's zeroed out. We know that. So let's file, export, FBX. So I'm going to again go to the skeletal mesh. So I got everything. Just the way it should be. I'm just going to call this attempt to skeleton.fbx. I'm going to export that. And then I'm going to file, export, FBX. And I'm going to choose animation. And so I'm just going to leave it just the way it is. And I'm going to call this attempt to skeleton, or attempt to anim01. Export FBX. It's odd, I've never had this issue before, maybe because of 4.9. So I'm going to import the skeleton first, attempt to skeleton. So again, I'm going to import a skeletal, import mesh, no skeleton. We're going to generate one. We're going to use T0 as reference pose. Everything should be fine on its own. We don't want to import animations, so we'll import. And so at least we can see that it's might be an animation issue. We might have to choose different options with 4.9, because if we go to the skeleton and we choose the root or whatever, or the spine, we can obviously affect it in different ways. So we know that it's working in that way, so it's just the animation. So I'm going to import the animation. I'm going to choose the skeleton. App temp, I didn't spell that right. Exported time. I'm going to import. That worked, no errors. So now if we import, we see we have our animation. So I think maybe you need to animate it and then export it in both ways. I think if you don't have an animation when you export the base, the skeleton, then it doesn't work. I think that's the issue we had. So that is how you do static, skeletal, and animations from Blender 2.75 to Unreal Engine 4.9, and that is also how normal errors work and how you can fix them. So hopefully this has helped the user that wanted some help with it. And yeah, that'll be about it. So thanks again for watching. From the team here at UnrealTek.net, a division of BlenderTek.com. You can go to the website UnrealTek.net to download projects, meshes, all blueprints, all sorts of things. If you enjoyed this video and learned something, please like it. Don't forget to subscribe for more videos. We're on social media on the links on your screen. If you disliked this video for some reason, please tell us why so we can continually improve our videos based on your community input. We also take requests, so we'll see you next time. Remember, create your way.